Hi guys, I hope everyone is doing well. I am doing well as well. So today we're looking at simultaneous equations, right? So this video I'm not going to be doing any formal example. I'll be just taking you through what simultaneous equations are. So basically simultaneous equations, I'll come back. Okay, maybe let me define them. Simultaneous equations are basically this is a very mild definition, basically where you have to find x and y, right? So you're looking for x and y at the same time. Normally in our normal equations you will be looking for y or x alone. In this case you're looking simultaneously for two variables, x and y. As I've said, this is very mild. This is actually not a description. This is not a definition, by the way. Let me call this a description. This is the description. Let me just do that properly. That's a description. It's not the definition. Description. I'm basically describing what is happening here, right? So you have to find for x and y, and as you would notice, there is some recipe on how to do that, right? And that basically brings us to about 3 methods, right? So we have about 3 methods to do that, and they include, number 1, they include where you have to substitute. I'm running a substitute, yes, where you have to substitute. I'll show you how it works. Number 2, where you have to equate, right? Equate, and these are going to be coming clear just now. Maybe I'll just dig deep into them for a second. And maybe where you have to eliminate. So basically the way we know how to solve equations so far is that we need to deal with one variable at the time, right? Basically we know how to deal with one variable at the time. Even here we will try to find a way of dealing with one variable at the time. So so with the substitution, what you will basically do, you will write maybe one of the variable as a subject, and then take that variable, substitute it to the other equation, and that's why it's called substitution, right? With where you have to equate, you basically gonna equate the equations both to the same. You're gonna make the subject y in both equations, and because they are both y, that claims that they are equal. And I think this is quite important, or maybe quite very interesting, right? This is very interesting. Come back to that in a moment. And then where you eliminate, you try to get rid of the other variable and sort of like deal with you eliminate one, and then you are left with one, you solve it, and then when you found it, you substitute back, right? So okay, so I want us to also talk about what does this actually mean. Why are we doing this, right? Why are we doing it? First of all, just to solve problems. Why do we do it? The first reason would be just random, just to solve certain problems. Right? This is, of course, this is very vague. Just to solve certain problems. It's not doing the job. Problems. And what kind of problems are we trying to solve? Suppose if I'm just looking for a tutorial now, I have a tutorial in front of you. So there's on page 8, there's a question that says the sum of two numbers is 111. So they're saying there are two numbers. I'll make the numbers A and B, right? So they're saying the sum. Once they say the sum, it means the addition. The sum of the two numbers, the sum is equal to 11, and their difference is, it's 111, and their difference is 11, right? and that's equation number 1, that's equation number 2, and the process is, or maybe what you have to do is to actually solve what are these numbers we are talking about. So that's what I mean by just to solve problems. But this has actually a very maybe a good reason why do we do it, right? Maybe let's say, why do we do simultaneous equations? Again, simultaneous equations. Again, so this is like part 2 of why we do it. Number 1, just to solve problems, but number two, it's probably for some interesting reason. And I'll draw up a function here, right? So suppose you have that function, that Cartesian plane, and this is y and this is x, and what you would do is, or what you would have is, you will have a function. Say that function is y is equal to 2x plus 2, and you will have another function. Oh, that's not a nice pen, given that I'm using it for a different reason. That's not a real nice eraser either. Let me just find a nice eraser, probably here. Good. Okay, so let me see. I was trying to find another function. Maybe we have another equation here, which is y is equal to 2x plus 4, right? So that's at 4, that's at 2. And you can clearly see that this function meet here, right? So these function meet, or you can say that they intersect. Right? And basically what you are interested at what point do these function intersect? Maybe let me just undo what I just did. What is this particular point at which this function intersect? At that point, you are concerned about the x value, because remember, any position in a Cartesian plane is mapped by 2 numbers, x and y. So at this moment, you are just like very curious about what is the x value and what is the y value at which this function intersect, right? Do you see now suddenly you are concerned about 2 things? You are concerned about x, and you are concerned about y, and you are concerned about x. So to solve this problem calls for some simultaneous equations. And I'm going to do this one. I'm not going to do all of it, but basically you have y is equal to 2x plus 2 as your first equation, and you have y is equal to minus 2x plus 4. So what you're going to do is saying, okay, definitely at this point, these functions are the same. They are sharing the same y. So this y is the same as this y, right? That y is the same as that y. And I'm putting them in quotation marks, right? But maybe because I have a color coding, I can just say this y, which is the top y, is the same as that y, right? And what you can basically say, you can say, then this is 2x plus 2 is equal to minus 2x plus 4, right? And now at this point, you can realize that, oh, hectic, you can solve for x. You can take that to this side. This is going to be 4x. You can take the 2 to the other side. It's going to be what? 4x, it's going to be 2. And you will find that x is 2 over 4. So x is a half. So you can take that x and substitute in any, because what you've done, basically, you find this x value at which this function intersect, right? And you can take that x value, put it in any of these equations. Whether you put it in this equation, you will still get the y, and that y would be the same as when you put it in this equation, because they share the same y. So that's really the importance of simultaneous equations. Now, I said one of the methods are very interesting, and it's because we use it to solve problems like this, right? So